Hello, my name is Jesse King. I'm a service forester with the West Virginia Division of Forestry, and today we're going to learn a little bit about science and fire, how first responders and foresters put out wildfires, and how fires work on a chemistry level. So let's have fun. Okay, to start, we're going to have to learn a little bit about fire and what makes up a fire. So we refer to this as a fire triangle because we have three parts that make up a fire, being heat, oxygen, and fuel. A little thing you can do to experiment with heat is you can take your hands, rub them together really fast, faster, until you can't take the heat anymore, then put them up against your cheeks. You can feel that heat. That's actually energy from friction. That could be an example of heat. Oxygen is the same oxygen that we breathe as human beings. A fire also needs to breathe. So if we take a great big breath, then we'd be building up our flame, and then we'd exhale, and then we'd take another big breath. So a fire needs to do the same thing to survive. It also needs fuel or food for the fire. So as it goes through the forest floor, it takes in leaves, old woody debris, branches, trees, things like that to fuel the fire. So lack of fuel could also mean lack of fire. If we would take out any one part of this, we would no longer have a triangle, right? We'd only have two parts. So if we take out the heat, we'd only have oxygen and fuel. That is what is in our normal forest every day. And it's not on fire, right? So if we would only have heat and oxygen, it would just be like a dry day in a hot parking lot, but it wouldn't have any fuel, right? So if we took out the fuel, so on and so forth. So we're going to talk a little bit, we're going to do some fun experiments that you can do at home and show if we would take one of these factors out, how fire goes out. All these experiments that you're going to do from home, we can usually find all the items in your home, but you'll need a trusted adult. That's the number one thing that you'll need for all these. So number one, trusted adult. I'm a trained professional, so I'm able to do these activities with you right now, but at home you'll need an adult. So first thing you'll need is a lighter as a source of heat. So if we light our lighter, there we have a flame. This is going to be the start for each of our flames in our activities. So this represents our heat. The next thing you'll need is a candle. The candle is going to represent the fuel. What most people get wrong about a candle is they look at a candle and they say, well, what part makes the fuel? And they'll say the wax. Well, the wax itself never does catch on fire. What does it do? It melts. What actually catches on fire with a candle is the wick. The wick is a fabric, which could represent like a plant-like material. So if we apply our heat with our fuel and then all the available oxygen that we have around it, then we would end up with a flame. So there we have plenty of oxygen, we have all the oxygen in the room, endless supply. We have our fuel, which would be our wick, and we have our heat, which is now our flame. But let's say that we wanted to take out one of those things from the fire triangle. In this instance, we want to take out the oxygen. Take our candle, we place it on our lid. Then we take our jar with a fixed amount of oxygen available inside. Twist it on so that way we know that it has a tight seal and no oxygen can get in it. Now we can start counting 1, 2, 3, 4, and then we see that all of the flame is out and that the oxygen is no longer available, right? So it used up all the oxygen in order to make the flame. Once there is no more oxygen available, it puts the fire out. This would be the same example as wildland firefighters smothering a fire using retardant or some kind of material like that. We took away all the oxygen available to the flame. Okay, so for our next experiment, once again, you always need an adult available. Next thing you'll need is a plate, just like you'd find in your normal kitchen. So we've got a plate. We need some water, so we've got a little bit of water in a pitcher here. Okay, we're going to pour enough water just to get on the bottom surface of our plate all the way around before it starts changing tilt. It's that little bit of a slope. Okay, now it's a little bit difficult to see the water for our experiment, so what we're going to try to do is we're going to take a little bit of food coloring. 1 drop should be efficient. If you want to make it a little bit darker, you could use 2. Try not to make a mess. There's 1 and 2. Okay. Using a utensil, we'll mix up our food coloring, making our water to where we can see it for our activity. Okay, next thing we're going to need is a flame, just like we've been working. This time we're going to use flatter tea-light candles. Each of these candles are going to be their own individual flame. So first of all, we've got our heat as usual, our heat represented from the flame from the lighter, our fuel represented from the wick of the candle, and then our available oxygen, which is the oxygen surrounding in the room. Now we're going to take a clear bowl or very large jar, and we're going to kind of do the same experiment as candle in a jar, in that there's only a finite amount of oxygen available within the bowl. So now, placing the bowl down and getting a good seal with the plate, we can see as the flame starts burning out, taking up all the available oxygen, we'll see the water disappearing up into the bowl, creating a form of suction as it draws, uses up all the oxygen and still trying to draw to create a flame. It creates a suction up into the bowl. This is a visible example of lack of oxygen. Okay, for our next fire lesson, preferably maybe find a sink or a metal tray or something so that way you don't get your area wet. But we're going to go over heat. So first of all, to start, we're always going to start a fire the same way with an adult. But then we have a lighter representing our heat, our wick representing our fuel, and then available oxygen surrounding the candle. Okay, so you'll need 2 balloons. So first we have a green balloon. This one is just filled with oxygen alone. So we just filled up the balloon naturally. If we would take the air that's in this balloon and we would hover it over, then what would it do? It would pop, right? Because the area on the surface of the balloon would heat up, and then making it expand and pop, also heating up the molecules for the air that's within it. So we're going to pop the balloon. So there we have a large pop. So now if we take a balloon that actually has a little bit of water swishing back and forth in the balloon along with the oxygen, and this is cold water, by the way, that's what you'll want to get out of your sink, you can hover it over the fire itself, and notice that this time it's not popping the balloon, even though we've kind of touched the flames onto the balloon. That's because the water is transferring that heat and ultimately cooling it down, not allowing the water in the balloon to pop. This is transfer of heat and how water takes away a flame. Okay, this next activity that we would do, this is called Matchstick Forests. So the things you're going to need is you're going to need some Play-Doh. You can make this Play-Doh at home or you can buy from the store. There's plenty of recipes online for homemade Play-Doh. You'll need green. Green represents a landscape or the normal earth and vegetation. Yellow could represent a sandbar, something like that, a beach. Water is represented by blue. And then any structures, homes, or roadways represented by purple. You'll also need various steel trays, metal trays. They can be any size that you'd like, depending on how big of a landscape you want. You can use matches. Preferably, it's nice to get these green-colored matches because it represents a little bit more of a forestry setting. And then you also need a lighter for your heat. Okay, so here we can see a student's landscape. First of all, they have 2 different sections of vegetation separated by a barrier of water. This barrier of water could be a river, something like that. That would make it a little bit harder for a wildfire to spread in a natural setting. Next thing you can see is that the students made this section far more dense of a forest than this section over here. This can represent an area that needs to be thinning or an over dense forest, like say what they've got in California, versus an area that has already been selective harvested or thinned for purposes of making less debris to help control wildfires. Momentarily, we're going to take these outside and we're going to show you how fires travel on different landscapes. Our next landscape that we have, we'll slide it on over. This one's a little bit more advanced. We've got different slopes and terrain, as well as different sized timber. So these can represent different types of forest. This can be an early successional forest versus a much mature forest, right, on different slopes. We also have various different barriers, being roadways. We have homes and structures we'd have to worry about in a wildfire setting, and different streams. When lighting these for the activity, you want to do it outside. So let's go to a safer setting. Okay, as we take our activity outside into a safe environment, we still have our lighter acting as our heat, our matches acting as our forest floor, and also our fuel. Fires start in various different ways. This could have been a power line or any other kind of activity, but you can see how dense our forest type is here. This could be a forest type that isn't managed, has too many trees per acre, something like that. But you can see how fast and dense that the fire activity is in that forest type there. You can also see the trees or the matches as they burn. You still have leftover residue, things that would need to be mopped up by different fire departments, things like that during activities. But you can see how harsh this would be on a normal environment. So as we manage our forest, we try to make forests that are less dense in competition. Now on this side we can see an area that maybe had a selection harvest, maybe taking out every other tree. It would have less trees per acre, and you can see that since the crowns are not touching, our spread of our fuel is lessened. So even if we tried to move our terrain to make a steeper slope that would normally help a fire travel, we still don't get that much spread due to the less amount of fuel in our forest. And that comes through forest management activities. Okay, for our second tray that we got here, like we said before, we have all these different forest types: early successional, dominant forest, heavy forest. We have some mixed different types of cuttings and different things. So we're going to start with our early successional forest. You can see the flames are much lower, much smaller, because we have a lesser fuel type, right? So usually in these, we can get a fire that maybe spreads a little faster, but spreads with less intensity. Here you can see trying to move the terrain. The steeper the terrain, remember, the more that a fire can move. Okay, so moving on with a different, with our source of heat, lighting a different forest type. We can see that we have an urban area next to us. Those roadways, different sections like that. The rivers and roads could be blocking fire travel. Behind a structure, we could add a fire that got loose. As a fire moves uphill, it does move with more intensity. We can see it traveling upwards, up into, from a small forest type, early successional, up into a more dominant heavy forest type with larger intensity of fire. Okay, now back over to a harvest-like area where once again we removed so many trees and we have a proper spacing. Notice that our fire is not spreading, right? So these are activities that we can use in different areas of the United States, say like in California, where if we would lessen our fuel loads, we could actually have less detrimental fires in the area. So now starting from a bottom of an area and working back up, you can see how steep that terrain is without moving the tray or anything. We're going to move it slightly. Then we can see that it gets started and starts working up into the crown. And then we can see how fast that it moves. Now jumping the river, because of our high intensity, it actually jumped over into our other forest type. But this time notice that it's working its way downhill. So it's not burning nearly as fast as what it did when it was burning uphill, because the flames have to reach down across themselves instead of reaching up into a fuel type, feeding the fire like we talked about in the fire triangle. but you can see how dense that forest is and how high the intensity was. So that ends some of the activities that we have for fire. There's these activities and more found through Project Learning Tree at plt.org. You can also talk to any service forester with the West Virginia Division of Forestry and communicate with them for some projects in your community. Over $5 billion gets spent every year fighting and suppressing wildfires here in the United States. It's very important, but fire is an important part of our ecosystem as a whole. We want to try to suppress wildfires, but we also want to use them responsibly. When doing these activities, remember to have a parent at home and have fun.